All right, so let's take a look at some types of problems, or at least a problem for calorimetry experiments. So here, this problem is describing we're taking an unknown metal and 253 grams of it, and it's at 54 degrees Celsius. And we're going to put it into a calorimeter. So pretend that's our calorimeter. Doesn't look very high tech, but it is what it is. And that water is at 25 degrees Celsius. And then we have 75 grams of it. So eventually, over time, the heat from that metal will transfer to the water, and the metal lowered its temperature to 37.2 degrees Celsius. The water increased its temperature to 37.2 degrees Celsius. And since we don't know what this metal is, we need to find the specific heat capacity, and then we can identify it from the table that's shown there. Now, what confuses students in the beginning is we've we've done some problems or have seen formulas for at least two different things. One was for where we just used Q, and we did a problem like that. And then in the last video for calorimetry, we had Q, the negative Q of one substance equals the positive Q of another substance. And just a little tip, whenever we're dealing with calorimetry, we want to use this because we're dealing with the the transfer of heat between two substances. And so in this case, our formula will look like this. Negative Q of the metal equals the Q of water. Because the metal is losing heat, the water is gaining heat. That's why there's that difference in sign there. So let's take now this formula and plug it in on both sides. So we'll have the negative mass of the metal times its specific heat capacity times its change in temperature. And then we'll have the mass of the water times its specific heat capacity times its change in temperature. Now let's go identify all of those things up in our problem here. Okay, so here we have 253 grams of an unknown metal. Well, that's our mass here. And it was heated to 54 degrees Celsius. So I think what I'm going to do is change these terms here to make it T final minus T initial for the metal. I'll do the same thing for water here. Just so we can label every single number. So the metal was heated to 54 degrees. That's its initial temperature. And then it was quickly transferred to calorimeter containing 75 grams of water. So there's a new value. That's the mass of water. And the water's initial temperature was 25 degrees. So that is there. And then finally, the final temp of both the water and the metal was 37.2 degrees. So I'll use that. And the TF is going to be the same for both the metal and the water. Now, we do know the specific heat capacity of water. We're looking at the table right there. So let me get one more color here. Which one should I use? I'll use orange. The specific heat capacity of water is right there. So I've identified where everything should go, and I know that I'm going to be solving for the specific heat capacity of the metal. All right, so I'm going to rearrange this equation to solve for that, and then let's plug our numbers in. So I have the mass of water, specific heat capacity of water, and then TF minus TI for water. And that's going to be over the mass of the metal and then TF minus TI of the metal. All right, so let's plug everything in. So the mass of the water was 75 grams. Its specific heat capacity is 4.184. And then its change in temperature looks like this. And then for the metal down here on the bottom, I have negative 253 grams. I mean, grams can't really be negative, but that's the sign that I'll just put it on the outside here so that doesn't confuse anybody. And then the change in temperature for the metal. Kind of notice something interesting here because this calculation right here is going to end up being negative. And if that's negative and we got a negative sign out there, that's how we're going to end up with a positive number. So we don't have to worry about the sign ever coming out to negative. Specific heat capacity should never be a negative value. All right, so then you're going to toss all of that into your calculator, keeping track of your significant figures. That comes out to a value of 0.901 joules per gram per degree Celsius. That's the specific heat capacity for our unknown metal. And if we go to our table, that's really close to aluminum there. So that's going to be our answer. If I go back and kind of take a look at our units here, notice grams top, grams on bottom, Celsius on top, Celsius cancels out there. And my remaining units here are joules over grams over degrees Celsius, which is what I should get for specific heat capacity. So remember, I've always recommended like keeping track of your units because that will help you determine if you've set up your problem correctly. So I've seen a lot of calculations on some of your assessments where you weren't keeping track of your units and they didn't cancel out properly and you weren't coming to the right answer. So, and whether you're doing unit conversions or whether you're doing problems like this where you plug stuff into a formula, your units should come out correctly to what you're trying to solve for.